Okay, Bismillah ar-Rahman ar-Rahim. Today we will be studying a new topic, and this is taken from chapter number 10, Flat's book. The topic name is frequency response of amplifier. Now, we from the past few weeks we are studying amplifiers, and the study of amplifiers can be broadly classified into two groups: the amplitude response and the frequency response. In amplitude response, actually, you are more interested in studying the voltage gain, current gain, and the power gain. And we study different modes and techniques to enhance, let's suppose, voltage gain. So remember that let's suppose someone asked you that how we can increase the voltage gain. So you can instantly says that we can increase the voltage gain by cascading amplifiers, and we also studies different configurations, and we know all about that. In the power gain, a power gain is basically what we did is for the power gain we study different classes such as class A, class B, and class C. Now over here the frequency response, we are studying low frequency response and high frequency response. In low frequency response, basically we are studying the effect of frequency response on voltage gain. So how can we increase or decrease the gain, and what will be the effect of frequency response? So till now we were assuming that we are not assuming any frequency effect in the amplifier circuits. We assume that the amplifiers are working, the conditions are ideal conditions for frequency. But over here we will be studying in detail the effect of the frequency response. So basically we defined we categorize frequency response into low frequency response and high frequency response, and we can see that the frequency response, this is the amplifier. For instance, we have a typical class common emitter amplifier where your emitter is ground, okay, and your input is applied at the base, and you can take out the signal from the collector, okay, through this RL, and this is the gain of a typical class amplifier, we can say, but this is common emitter amplifier. So the typical voltage gain is RC divided by RE prime, and this is the relation. This is a relation of frequency and the reactance of the capacitors. Now we know that when we talk about frequency response, so we can assume in this amplifier circuit, okay, the significant part which is basically which can be affected by frequency is the capacitors. So basically we have three capacitors, C1, C2, C3. So it means that these three capacitors will show different behavior under different frequencies. So under low frequencies their behavior will be different, under high frequencies their behavior will be different. Now C1 and C3 we call these as coupling capacitors, and C2 we call this as a bypass capacitor. So let's talk about the low frequency response of this amplifier. So we know that under ideal condition, if you see like if I write over here, okay, under ideal condition we assumed that this SC1 will be very small for a frequency, operating frequency, and we can assume that this XC basically it can be equal to 0. So this was a clear assumption we did last time. So whatever, when this XC is equal to 0, this is when this occurs, so basically what happens that the signal will go and it will find the C1 as a short circuit, okay, as a short path, right, okay, and then it can be readily available at the base of this amplifier. Similarly, if the signal is over here in the collector terminal, so it finds the C3 as a short path towards the RL. And similarly the case for the emitter, in the emitter branch, uh, the the signal will find a short path, and it will go in this way, okay, through C2. The signal in that case it will never go through CRE. So basically this RE is bypassed. But this occur and this happens when XC is equal to 0, and it is under ideal conditions, right? Under practical or real situation, okay, non-ideal condition, what happens that this frequency, if frequency increases or if it decreases, so basically it would change the value of this XC. Now by changing the frequencies, we mean by changing the frequency of this input signal, right? Okay, so let's suppose if you talk about that, if we let's suppose we decrease the frequency. So let's suppose if the frequency of this input signal is decreased, right, is decreased. So basically if this frequency goes, okay, it is decreased, so this inverse relation, okay, they are inversely proportional. So basically it means that XC would increase. So when XC increases, okay, the reactance of this capacitors, particular C1, when it increases, so basically what happens that when a signal comes over here, so there will be a drop, okay. So XC is not now equal to 0, so there is a drop in this branch across C1, okay, and due to this branch, okay, there is a reduced voltage at the base, so it would reduce the overall gain of this amplifier. So that's why we say as frequency is low, reactance of C1 and C3. So similarly over here the same phenomena can apply in the C3, okay. The signal will be significantly dropped over here in this C3, okay. Why? XC is not equal to 0, okay, it has some value. So basically when it happens, so the overall voltage will be decreased, right? Okay, and okay, so reduction in voltage gain would occur at low frequencies, and also it would produce a phase shift, okay. So basically this is a property of RC circuit. So whenever you have a formation of RC circuit, so there is introduction of a phase shift, so either leading phase shift or lagging phase shift. In this case we'll be proving later on that it is a leading phase shift. So basically a phase shift occurs at over here in this branch, a phase shift occur over here in this branch. Now the bypass capacitor over here, okay, the same thing can be applied for the bypass capacitor, okay. When this becomes non-zero reactance, okay, XC becomes non-zero, so what would happen that the signal would get divided, okay, in the emitter over here. So the signal would get divided through ZE and this RE. Now the gain, if you see, now it is previously this gain was only in the denominator, it was only RE prime. Now over here the gain is in the denominator, it is addition of ZE. So basically when this term increases, actually this term increases, so it means the overall gain would decrease. Now similarly for the high frequency response, now the high frequency response, the effect would be at high frequency, okay, if I increase the frequency of the input signal, okay, of this input signal, so what would happen that I can remove this one. So basically what would happen that XC would decrease, okay, this XC would decrease, but high frequency would results into the formation of junction capacitors between collector and base, and between base and emitter. So again it would reduce its voltage gain, and this would produce a phase shift as in the case of over here. Thank you.